Hi friends, this is Vishnu here. Welcome to my channel Tips, Tricks and Concepts by Vishnu. So in this video I am going to continue with isomerism. Okay, so here I will be telling about EZ isomerism, okay, which is needed for your exams. Only the details that is required for your exams about EZ isomerism. So I am not going to keep you waiting. Let's go to the topic. Okay, but before going into the topic, you have to learn why such a system of EZ isomerism exists. This is because if we have the geometrical isomer, that is, if the double bonded carbon atom of the geometrical isomers are having three or all the four substituents as different, okay, all the four substituents or groups attached to the two double bonded carbon atoms are different, then it is not meaningful to tell it as cis or trans, okay. So that's why we have to use the EZ system of nomenclature, okay, EZ isomerism. So in this system we use a sequence rule, okay, that is which groups have to be given more preference or given more priority, okay. It is the same rule that is used in another system, that is R&S system of stereoisomerism, okay. So it is called as Can-Ingold Prolog system or CIP score, okay. So this question is a very important question, that is it can be asked as a EZ isomer or an R&S isomer or according to the CIP score, okay. Regarding the E and Z isomer, it has been asked in one of the previous year's question paper, and regarding the CIP score, there are questions there in your NTA mock test, okay, the mock test given by your National Testing Agency. So you know the importance of studying this EZ isomerism, okay. So let's go to the rules for giving which group as more preferred or which group is having the more priority, okay. So there are only 4 rules and we can learn those 4 rules with great easy, okay. So let's go to the topic. So friends, let's go to the first rule, okay, that is the atom of the highest atomic number attached to this double bonded carbon atom gets the highest priority, okay. So we are having 2 carbon atoms, double bonded carbon atoms, and in each of these double bonded carbon atoms we have 2 substituents each, and in each of these substituents are given preference in such a way that the atomic number of the element to which the double bonded carbon atom is attached. For example, let's make it clear by using an example, that is we can take the case of our 1 bromo, 2 chloro, 2 fluoro, 1 iodo, ET, okay, that is all 4 are different halogens. So how to know which priority to be given preference and how to name this isomer, how to name the isomers of this particular compound, okay. So first of all, let's take the case of this particular arrangement, and hence here we have 1 carbon, okay, the first carbon has bromine and iodine in it, and the other carbon has the fluorine and chlorine in it, okay. So according to the atomic number we have to denote the groups as a higher prior group, okay. So here we have bromine and iodine, okay. So here iodine is given the highest preference and bromine the lowest preference, okay. And there in the case of the other carbon atom we have chlorine has a higher atomic number, and hence that chlorine is given the more preference and fluorine the lesser preference, okay. In a similar way we can arrange the substituents in a different order, okay, different arrangement, that is we can rotate 1 carbon atom, okay. So we can denote its arrangement in such a way that the higher prior groups are on the opposite sides, okay. So here we have to note the another rule, okay, that is the main rule, that is a principal rule, okay. That's I actually meant to tell at last, that is actually the rule 4, but I will tell it as the principal rule, that is the main rule for all these isomers. That is, the rule is that if the atoms, okay, if the higher prior groups are on the same side of the double bond, then those isomers are called as Z isomers, okay. Those isomers are called as Z isomers. Now if they are on the opposite sides, like in this case we have this isomer is called as the E isomer, okay. How to remember it, okay, it's very easy, that is you can remember E to be enemy, okay. So E means enemy, so they are on the opposite sides, and Z means as usual what is left over, that is the same, okay, they are on the same sides, okay. Now let's go to the next rule. the rules does not finish here. We have to look at more complex compounds. Okay, so there are two more rules. So friends, the next rule is that if both the groups attached to the carbon atom, okay, double bonded carbon atoms are attached through the same atom, okay, having the same atomic number, that is as shown here. You can see that in the first case, okay, in the first carbon you can see that a CH2Cl group is attached. So the linking element is again a carbon atom. Okay, in other case we have a CH2OH attached, but the linking element is again a carbon atom. And here also if you look, there are two carbon atoms as the linking element, okay, directly linked element. So we have to use the second rule. That is, the second rule here is that if such compound comes, then we have to refer the next element, okay, next directly linked element, or all the other next directly linked elements. For example, in the first case you can see CH2Cl. So we have two hydrogen atoms and a Cl element attached to the carbon atom. Okay, and in the other side we have CH2OH, that is two hydrogen atoms and an oxygen atom directly linked to this carbon atom. So you can see that naturally this chlorine atom plus these two hydrogen atoms will have the more atomic number, and hence that group is given more preference. Okay, that group is the higher priority group. Okay, in the same case if you look at in this carbon atom, you can see a methyl group and an ethyl group attached, but here in case of the methyl group, the other linked, the secondary linked carbon atoms to be more precise, are three hydrogen atoms, while here we have a carbon atom also. So naturally this ethyl group is given more preference, okay, more priority. Okay, so here this compound we can tell to be an E isomer. Okay, now the next rule. Okay, now we are looking at the next case, that is if the carbon atom, okay, double bonded carbon atom is attached to a carbon atom in such a way that, or any other element in such a way that it is having a double bond or a triple bond with another compound, okay, with another element. Okay, so for example, let's take the case of an aldehyde attached to the carbon atom. Okay, so we have to assume the second rule. Okay, assume the second rule, that is if the other group is also linked to this double bond through a carbon atom, then we have to assess the second rule in such a way that this C double bond O in our CHO is considered in such a way that this carbon atom, okay, this directly linked carbon atom is having two bonds with the oxygen atom and one bond with the hydrogen atom. Okay, so in a similar case with a carboxylic acid, say COOH group is attached, we can see that we have to assume as if the carbon is attached to two oxygen atom by that C double bond O and one oxygen atom by that COH. Okay, so we have to think in that way, that is if there is a double bond, it means that this linking element is having two such atoms in contact. Okay, in that way you have to think. Okay, so it can be shortly said that a double bond as well as a triple bond should be considered as different single bonds. Okay, different single bonds. So that is, in other words, the double bonds or the triple bonds are treated as if they are duplicate or triplicate single bonds. That is, if a C triple bond C is attached to the double bonded carbon atom, then we have to think that secondary linkages as if the carbon atom is attached to three other carbon atoms. Okay, now the next rule, that is the next case, that is if the carbon atom, if the double bonded carbon atom are attached to the same element. Okay, if a double bonded carbon atom is attached to the same element but having different mass numbers, that is they are different isotopes. Okay, if the double bonded carbon atom is attached to two different isotopes of the same element, so in such a case, as shown here, you have to choose the higher mass number isotope as the more preferred, or the group with the more priority. Okay, so in this case we have, following this rule, we have the iodine 131 has a higher priority than iodine 129, and hence this isomer, by following all the other rules, we have it as a Z isomer. Okay, now last but not the least, we will deal with a special case, that is oximes. Okay, so it is also very well important for your exams, and after this topic I will finish it. Okay, so here we have the oximes, and here we know that we have a C and N with a double bond. Okay, and this nitrogen atom has a lone pair of electrons and OH group on the opposite side. So here what we should know is that the only group that is attached to the nitrogen is OH group. Okay, so without any other thinking or without any other further thoughts, we can take this OH group as the highest preferred group, okay, than the lone pair of electrons. So please don't confuse it with syn and anti. Okay, in the syn and anti cases it was entirely opposite, but here in E and Z system it is we are following the higher priority order, the sequence rule. Okay, that is scan, ingol, prolog, sequence and all. Okay, and hence we are taking this OH group as the more preferred group. Now the other groups, okay, we are assuming it as an E or Z isomer just by applying all the other 4 rules to the carbon atom. Okay, that is the double bonded carbon atom. That's all. Okay, so here we have the phenyl group on one side and the methyl group on the other side of the carbon atom of the double bond. So naturally we have here, if you look, we have this carbon atom. Okay, the directly linked carbon atom is attached to 3 carbon atoms, right? Because we have the phenyl structure as shown here, and hence this carbon atom which is attached to this double bonded carbon atom having secondary linkages with 3 carbon atoms, so it is having more preference than the methyl group, and hence this phenyl is taken as a more preferred group, and hence this is an example for E isomer. Okay, so friends, that's all about EZ isomerism that is required for your exams, and if you have any doubts, please feel free to ask me, and I hope this has been very useful for you, and I will get back to you with more such videos, tips, tricks, etc. So if you haven't subscribed my channel, please subscribe my channel, and bye bye and have a nice day ahead.